is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all sings with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Hey everybody, welcome to SkyTour live stream. It is me, Mark D'Antonio. Nice to see you all here. We have a heck of a night planned for you tonight. As you can see, we've got that thing in the sky, but you know what? You might notice it looks pretty nice right now. And it does. We've got a really nice view of it tonight. I want to say hello to everybody that's in here. I've been saying hi to you guys in the chat. I also want to do a shout out to Cosmic Ray. Cosmic Ray has helped us out lately, and it's actually quite nice, and we appreciate it. Thank you, Ray. And let's see. I want to say hello to Bun. I think Bun is Marianne's friend, correct? Out in California, where you are currently staying, Marianne, I believe. And that's pretty cool. Nice to see you all here. I am working tirelessly to improve SkyTour livestream, and we're trying our best to get it to do some cool stuff for us, and seems to be going very well. We're very happy with how things are turning out here. And progress support, Benson, we are looking at trying to do some work before November in Benson to get that set up. And want to say, I don't want to sing it, but I'll say happy birthday to Michael Tarr, who is Calabos in our chat, works at SpaceX, and Tiffany is the person that calls the shots between the two of them, and she just said she's celebrating Michael's birthday. So yeah. So that's pretty cool. And meanwhile, one of the things I had got to tell you is, of course, that we have Daryl with us. Hello, Daryl. How you doing?
Hello, Mark. You'll miss me when I'm gone.
Well, what was happening was I was trying to find your checkbox to turn you on, and I think I covered for it pretty well while hunting for it. So I found it, and you're in, and we are good. So, Daryl, what's going on with the weather at your end? I heard you had some pretty bad storms, huh?
The usual afternoon monsoon storms rolled through, and they're all out east now. It's raining like crazy, or storming like crazy, and blowing and flash flooding and tornadoing out there.
Geez, that's pretty bad.
It's actually trying to clear up here.
Wow. Well,
I saw the moon a while ago. The moon's at first quarter, by the way. It was first quarter a little after 9 this morning, Mountain Time.
Oh, okay. Very
so
good.
It's a little more than half lit.
Yeah, a little past first quarter. Yep. Cosmic Ray says he's using C-Star on Mesher 27. Hey. You get out of Cygnus. That's our territory. I'm obviously kidding. Yeah, the C-Star is a nice little scope. It doesn't have the best resolution, but, if you want to get into astronomy, it's an easy way to get in. It's kind of an idiot-proof system, so it's really kind of cool that way. And I think that makes a lot of sense to a lot of people.
Prices are dropping on it, too.
Yeah, that's because there's a larger version coming out.
Ow.
Yeah. Every time a price drop happens, hey, Yep. I want to say hi to Jane Murdoch, who's here. And let's see. For those that I didn't say hi to in the chat earlier, I didn't say hi to Michael because he's not here. I just wished him happy birthday. Tiffany's here, though. That's the better half, anyway. So, Marianne, how's it going out in California tonight? Let us know.
Ain't that the way it goes?
Yep. Judy M is with us. Hi, Judy. So nice to see you. Eliza Raquel, how are you? It's so nice to see you as well. And we're just going to... we're waiting for it to get fully dark out there. Let me show you the AllSky so you can see kind of where we are right now. All right, this is our current view. All right, notice this little streak right here. That's actually a meteor. All right, this may be another meteor. It's got a little brightening in it, but it may not be. It might be a satellite. This is the moon here, so it's going to interfere a little bit. You get these rings from of reflection, internal camera reflection on the dome of the AllSky camera. So we'll see that. This is the rising Milky Way. It's cool. Gina Young is here with us. Hi, Gina. Yep. Marianne says, it's so beautiful and cool in California. And she says, not looking forward to going back to AZ. Okay, well, just leave the key at the door and I'll let myself in and change all the locks in your house and I'll just take over and I'll squat. Apparently it's hard to get squatters out of your house. Hey, the Goblin's with us. Long time no see, brother. Yeah. Hopefully you're using that equipment that you won from us. I hope you are. Cosmic Ray says the north turned all red about, and I think he hit the pound sign. What he really meant was 3 a.m. That's where the pound is on the keyboard. Yeah.
Bill had quite a display of bright red aurora on
Yeah.
his meteor stream last night.
That's cool. That's oxygen auroras. Very cool. This is neat. So we're looking at a really nice evening here.
Answer a question for me.
Yeah.
People typically think of oxygen as being green in color, O3 light.
Yeah.
Why is the aurora oxygen red? I have to guess it's a different ionization state.
It is, and it's also corresponds to oxygen at a different altitude. Okay, because when it's green, it's also oxygen in our auroras, and nitrogen tends to be blue. So you see a mix of blue and green a lot, and that is an oxygen-nitrogen aurora. And think about the components of our atmosphere, right? And I'm saying this to everybody, not just you, Daryl, obviously. But when we look at components of our atmosphere, it's obviously, mostly nitrogen with some oxygen. So at different altitudes, oxygen's ionization state will be different. So at higher altitude, we'll see more red, okay? But at lower altitudes, we'll see green. So the red is the high. And if you think about it, that makes sense because you see sprites and thunderstorms, and they're red, okay? Well, that's ionization that's occurring in oxygen at very, very high altitude, right? So some of these things are... they're related, and it's not the simplest thing to follow if you haven't done it before, or if you don't know about the colors of the auroras. But just think about the components in our atmosphere and know that the colors are generated by the molecules in our atmosphere. We're looking at a diatomic oxygen in our atmosphere, right? We're looking also, we have O3, which is ozone, as well in our atmosphere, but it's dominated by O2 when it comes to oxygen, and nitrogen is what's in our atmosphere there. So it's actually pretty cool. Really cool. And Karen Belmont is with us. Hi, Karen. How are you? How is Doggo? Yeah, go ahead.
I know when you see green tails on meteors, which is often the case during the Perseids, the green tail is also oxygen, I do believe.
Yeah, and you also you see the remnant aurora, basically, that the meteor created in the upper atmosphere. And I'm talking 90 miles up or more, right? So it's actually pretty interesting, right? Oh, Tiffany, are we doing a contest tonight? It looks like we are. All right, let me, now you guys know that we actually do contests here on the channel. And one of the things that we'd like to do is we involve Michael Tarr and Tiffany, who have been the most incredible people to generate, interest in our channel by actually calling and saying, hey, let's do a contest. So tonight, Tiffany says, and I quote, guess a number between 1 and 1,000, and the person that's closest will win a pair of Celestron Cometron binoculars. So a number between 1 and 1,000, guys. So if you put your numbers in the chat, they will not get lost, we promise. We got Tiffany looking at this. We've got me and Daryl, and we've got other people in the chat that are watching as well. So we are, and she says we will be picking 2 winners. Wow. All right. Keith Evans says 304. And Tiffany, will you message me the actual number, please, if you haven't already? Probably did it already, and I don't even realize that because I didn't look yet. All right. Gina Young says 750. Eliza Raquel says 753. Oh my gosh, this is like The Price is Right. 750, 751. Ugh. That's pretty cool. All right. Red Angel says 756. Judy M says 499. This is great. We got a lot of participation. And if you win, obviously we will send the binoculars. Actually, Tiffany and Mike will take care of that. They will send the binoculars out to you And the binoculars will be delivered directly to you at no cost to you. We're going to take care of all that. Red Angel only gets one guess, so you have to you can't keep guessing numbers, Red Angel. You have to decide on a number and pick it. So put the next text out, the next message, and make that your final number. All right. So yeah, we got the moon up right now, and we're just tracking the moon at the moment just to check it out. And we are at our we're in our low light mode. We're actually shooting this at 1 millisecond, 1.12 milliseconds, and that's because we are. Oops, sorry. That's because we are actually looking at a very bright object, and we have an extremely bright moon with a very sensitive camera. All right. Uh-oh. Karen Belmont says 1,000. Okay. Red Angel's got his final number, and it's 954. All right. So that's Red Angel's guess. So Tiffany and Mike, make sure that you count that. Jane Murdoch says 953. Well, keep going, guys. Cosmic Ray, can I phone a friend? Yeah, if it had, yeah. Yeah, well, that's funny. No matter how you look at it, that's funny. Okay, let's see here. Looking in my messages, let me go see if I've got something here. Here we go. Okay, this contest is only going to last about an hour, okay? And after this hour, we will announce the winner. And Tiffany will be watching for this. Okay, let me look here. All right. So let's, while we're waiting for everybody to come up with some really good guesses, let's go check out our planetarium connected to our telescope here. And let's go check out this little globular cluster right here called Messier 4. It's right nearby, and it actually looks really pretty tonight.
Always a good choice.
Always a good choice. All right, and we're going to go to our low light mode here. You won't see anything yet because we're actually at way lower than we need to be. But when I do this, bring up 1 second exposure, there it is, right there. All right, so there it is. Okay.
And you can already see the line of stars running through the middle of it.
Yeah, and Daryl's talking about this line of stars right here. Now that's just an optical effect. It's not actually an actual effect. It's just a.
Oh, it's a chance position of all the stars.
It is. Sorry, I was responding to Tiffany. Well, this is great. It's nice to return to contests with SkyTour Livestream. Hope you guys appreciate it as much as we do. We call it Troniak. We hope you relish it as much as we do.
Oh, God.
Ron Howard's little brother. How could you say, you know, come on. All right.
Howard.
All right, we're going to take a 12-second photo here of this beautiful globular cluster. We're going to go into deep sky mode. We're going to back out of low light mode, go into the live stack, and you'll see a previous one that I took, and that one's already up on the server. All right, there we go. So now, right now, none of the levels have been set. Okay, if you look at this line, it's way past that peak. All right, this white peak represents the average of the red, green, and blue curves. This actually shows it very well. But those red, green, and blue curves need to be aligned under each other to make the colors lined up properly. So I will balance all the colors like this. Okay, now they're all aligned with each other. Okay, and now this sky is the proper coloration. The curves change shape because now we have a new average curve, which is this white one. And this is the black level. We have it way on the other side of the curve, so it's missing most of the data. As we come back here to just before the peak, right about here, this gives us the best data. All right, and so if we let it decide what to do, if we just click this button, you'll see it does this. It's going to make it really bright. What I'll do is I'll take this mid-level and drag it down. That yellow curve represents the slice of the data under all these curves that we're taking. Notice that this is it right here. This is what we're taking in. Not this, but this. And it starts here at this left side. So it's a process that's sometimes not intuitive to many people, but this gives us what we want. Now what I'll do is I'll back out a little bit. You'll notice a slightly blue tint to the screen. That's because the full moon, the first quarter moon is just a little bit farther away to the west. Here is a satellite traveling through the field right now. Let me correct the color one more time, and we should get a better coloration here. And now our screen looks normal. This is the proper colors that we expect to see. And Measure 4 looks nice. I'll bring up the annotation, and you'll notice that it's already on Measure 4. And I'm going to just redo this plate solve just to line it up better. I found out something really cool too, and that is if we change positions here, it automatically labels everything in the field as long as we're within a few degrees of what we're looking at. Otherwise, we just redo it. So it's actually quite cool. Now we'll save this image with annotations already because that means we'll just get this object saved. All right, so if this is going up on the server, which will be available to you as well. So this is what's going to be up there. Look, there's another globular cluster because we're zoomed in a little bit. And so Measure 4 is down here, and then we got this other one over here. All right, near it. All right, so that we get these images, and they are up. Now, if we want to see that other globular cluster, all we have to do is move over because we're not looking at the whole field. I'm zoomed in a little bit. So if we zoom out like this, okay, you can see the whole field. No, I didn't center it, but I wanted to bring this down into the field a little bit. So it's kind of like that for now. All right, so we have our annotated image. I also discovered that when you do that, it pre-fills this up here with the object name too when you click on it and you say center it. So that's pretty cool. So here, let's try that again. Let's bring it up and let's say center in the view. Okay, this is all right. So now we're going to center Measure 4 in the view. But actually, I can't do that now because we're doing a stack on it. So I got to be careful. We'll do it after so you can see what it does.
When you see those two globulars, M4, the big one, that's, if I remember correctly, about 7,000 light years away.
Yeah.
It's actually in or close to being in the Milky Way itself. And when we see the other globular up there at the upper left, that's, if I remember correctly, like 38,000 light years away. So it looks much smaller and redder, and it's actually on the other side of the galaxy from us. Mark, people are saying they lost your sound. They can't hear you.
Okay, I'm back. I don't know what happened there, but I wanted to say, Tiffany Echo has said, if you haven't already, make sure you pick a number between 1 and 1,000 because we are running a contest tonight. And that contest is one that will result in 2 pairs of binoculars being given away. All right. So if you put the number in the chat, it's getting tallied, I believe, by Tiffany. And so I hope you guys will note that Tiffany and Michael are the ones that are have chosen SkyTour Livestream as their exclusive giveaway stream for the equipment. So we give away whole telescopes, we give away binoculars, and as we move forward, we're going to be giving away a night vision system as well. And it's going to be a psionics system, which is effectively like an electronic camera that can see in the dark in full color. It's the most beautiful thing. And by the way, tonight is the Perseid meteor shower, second day, basically. And that meteor shower with this particular night vision system would be stunning. You can see meteors that no one else can see because some might be faint, and you'll see them because this is a very, very good system. It's like a camera for those that are into cameras that is up at like 800,000 ISO. That means the sensitivity is like 800,000. Okay, that's pretty good. That's pretty good. All right, so let's go in here and save this image right here, and we'll save it exactly as seen. This will end up on our server in just about 30 seconds. So let's go to the next object. Let's go, first of all, we're going to go into our low light mode here, and we'll do it like this. And let's do our, we're going to zoom in here, fill the field, go back to our planetarium view, and let's go check out the next item we might want to go see. Right now, let's go do one other thing. This is something we really haven't done lately. I'd like to look at another object that is up here, and I'll just drive to it. It's a gorgeous little cluster, and what's funny about this cluster is it's easy to mistake it for a globular cluster, but it's in the middle of this Scutum star cloud. All right, and it's up toward Cygnus, where we're going to be heading to shortly, on the way up the Milky Way, as we ride up the Milky Way tonight, take a visit with all of our friends far away. And so we're going to go here tonight and check it out. Now, we may refocus once we get up there. That's something I like to do. Note the telescope is heading up. You can see it doing so right now. It's looking up in the Scutum star cloud. And there is the cluster that we seek right there. This is called Messier 11. It looks like a globular cluster, but it's not.
It's the wild goose cluster.
That is correct.
No, it's not.
Messier 11?
It's the wild duck cluster.
No, it's the wild goose.
Okay. Just for tonight.
No. It's the wild fowl cluster. Yeah, so this is a beautiful location. I'm going to move us over. We're going to move the telescope to the west a little bit, and I'll show you why. Oh, there goes a Starlink satellite through our view. And I'm moving to the west for a reason. And that's because this cluster borders on another satellite coming through right through the cluster. Look at that. This satellite borders on this star cloud that you can just start to see here. This is the Scutum star cloud. So you're going to see Messier 11, and you're going to see the star cloud here. It's beautiful. It's stunning. And if you take a deep picture of it, it kind of looks like a wet driveway. Hello, Cindy. How are you? Cindy, oh, she knows already. 3:33 is Cindy's guess. Sam S., I didn't say hi. Thanks, man, for coming out. All right. Now, here's what we'll do. I'm gonna set up our exposure here. We're gonna go here, and I'm gonna do this first of all. I'm gonna come in here and do a plate solve on this area, and they end up getting a lot quicker. See, and then what I'm gonna say is center the object in the view, and when I do that, all right, interesting things happen. All right, so it's gonna center the object in the view. All right.
It is?
Yes, it is. There it goes.
Oh.
Okay.
It looked like it was telling you to center the mount.
No, but if you'll notice, it pre-filled it up here, so I don't even have to put it up. Okay. And now what I can do, now that I've pre-filled this, I'm going to actually now move it over, and I'm going to, I won't save the image with annotations yet, but I'm going to move back to the west, and as I do that, I'm going to bring the star cloud back in. Then we're going to start our nice exposure. So this is good right here. Here's the star cloud up here. You can't miss it. It goes all the way through here. Okay. Meanwhile, if we look here in our status, you'll see that it's searching for the guide stars. It takes about 11 to 12, sometimes 14 seconds to find a guide star. This will be a 25-second shot. All right. And now we're guiding, as you can see by the numbers up there changing right here. Right. And it will do this now. Here's what I'm going to do. I'm going to start the live stack here. And you'll see the previous image of Measure 4 probably. Oh yes, it's blown out because I forgot to drop that, but now we'll be cleared. Okay. But Measure 4 is safely up on the server right now, so we're good. Yep. OCE Rams, how are you? Good day, Mark. Are you down in Australia? Saw your chat where you mentioned your USO encounter. Yes, indeed. It only ignited your passion to search more. Yes, it did. Yes, it did. And I've since spent, I worked for the Navy too a lot of the time, so I have access to other submariners, and this is not a once in a while occurrence. This is happening a lot, and the Navy has an official program to study these things that are out there. Really fascinating. There's our star cloud. Let me just drop this down here, and let's move this out of the way for a moment, and let's just pull this in. So now we can see Measure 11 in all its glory, and you can see the Scutum star cloud here, and the size of our field is 3 full moons across by 2 full moons tall. Okay, the moon's about 30 arc minutes or half a degree, so it's 1.5 degrees across, which is 3 full moons, and it's about a degree tall, so that's like 2 full moons. All right, 30 and 30, 30, 30, 30. So yeah, so here you see this dark area. This is dark nebula. This is dark nebula in here. That's dust. This is tendrils of dust out in the universe. This is stuff in front of this massive star cloud. So that dust is up here and the stars are behind it. And that's why the stars seem like they're not here, but that's actually dust. We can tell when we observe the sky here, we can tell because dust gives off a certain spectral signature that we can identify. So we know that it's dust and not an actual void in the night sky. Kelvin, what's up? Nice to see you. Richard Spencer, how are you?
And when we look at those dust clouds with the Webb telescope, we can often see right through them, depending on the wavelength.
That's exactly right. And that's, if we use an infrared telescope like the James Webb, as Daryl's alluding to, then yeah, we will see typically into those dark dust clouds and see the stars hiding within. That's another way that we know immediately that we're looking at dust clouds, of course. You know. Okay, now, go ahead, Daryl.
No, go ahead.
I was going to say OCE asked the question, what does this sort of setup cost? If I wanted to help expand the search, are there many projects for global citizen science? Yeah, we're also tied in with Las Cumbres Observatory right now. We've been named in a award in a program to search both for exoplanets and for missing stars. Sound familiar, Izabela? And this is something that I let Daryl and Izabela know recently. And so if we have targets that we want to look for, and this will be probably targeted at Izabela because she found missing stars in some of our imagery, and those missing stars could have been dwarf planets that were in the field happenstance right there. But with a telescope like this, all right, and I'll get to the cost and all that in a minute, OCE. This particular system can see pretty faint objects. We're routinely down in 18th and 19th magnitude stars, which means very faint objects. Global. Okay, if you look at satellites at the altitude of, say, GPS satellites, okay, geostationary positions, okay, they're 22,500 miles off the Earth in orbit. They're orbiting the Earth once a day at the same rotation rate as the Earth, or over the Earth at the same spot every day. Those satellites typically are about 17th magnitude, and we can clearly see them, in our imagery and beyond. So we're past 17th magnitude easily with this system. This system is a 10-inch diameter telescope, but it's running 25 times faster than the f10 ratio that it had when we started. F10's a F number, kind of speaks to the speed of the telescope. If you had an F1 telescope, it's extremely fast photographically, so you need only a few seconds to capture amazing stuff. If you had an F10 telescope, you've got to go hundreds of times longer to get the same result. So we opted for taking our telescope from f10 down to f1.8. So our system, a little more expensive, but the overall value of our system out there right now, we're looking at several tens of thousands of dollars right now. And that was all done through donations and people wanting to support us. And I don't make a dime. None of us make a dime on this. We do this out of our passion. So that's basically helps us. Now, on top of that telescope, that's just one. That's in the Sonoran Desert west of Phoenix by about 75 miles, where it's very dark out there. The clouds are dark against the sky over the observatory. To the east toward Phoenix, 75 miles away, you can see the clouds get lighter and lighter and lighter, so there's some glow that faint cameras can see but your eye can't. And then we're also setting up an observatory out in Benson, Arizona, which is 200 miles southeast of this telescope, and that one's going to be a high focal length system that's going to have a filter wheel, so we can actually go through and do spectra. We can do narrow band imaging, it's called, where we can actually see very, very faint objects and pull in just those faint objects. We have a similar filter on our system here, but it's doing all at once in color. So it's a one-shot color thing we're doing here. Out there, we're going to be doing separate black and white images that we will combine into a final color image. Then that gives us the freedom to do some very true research beyond what we can do here. So that'll be very, very helpful. And we can actually use that telescope to confirm findings we see with this telescope. And that's pretty cool. And that's the second telescope. The third one is a solar telescope that's going in here where I am. I'm in Connecticut. This telescope is actually 2,600 miles away from me out in the Arizona desert. And it's I'm running it from Connecticut. Let's bring this back for a second. Okay, so this telescope you see right there, that's out in a building in Arizona, and I run it from Connecticut. I take the roof off from here. I operate the telescope from here. I have software to connect the telescope that is built into most telescopes these days, and it allows us to do some beautiful views. Like this is a beautiful view of the Milky Way, and this Milky Way is right up here in the sky. And if we pull back a little bit, you can see kind of where we are. And here is, go ahead, Daryl. I figure you want to tell them.
Well, we're in Scutum right now. Scutum. Scutum means shield, specifically a Roman shield, like what Roman soldiers used.
There you see it.
And just below Scutum there is Sagittarius, the teapot. The archer, it looks like a teapot. That's why we call it that.
Right. There's the teapot shape Daryl's talking about. There's the body of the teapot. There's the spout. And there's the top of the teapot. And there's the handle.
And the center of our galaxy is just off the tip of the spout of the teapot.
That's right. So if we zoom in, now we're still taking a picture here, so that's fine. But as Daryl says, the area just off the spout, which is right here, the star Al-Nasi. Al-Nasil, yeah.
Means arrow.
You can see right here, this is called Bod's window. This is actually the clearest view. It's sort of a clear view. Through the dust, the dark dust that's in the universe in this spot in the galaxy, and through that hole, you can actually see further than anywhere else toward the center of the galaxy. It's actually the clearest window, the furthest that we can see, and it still doesn't get us all the way there, but it's pretty cool. So. And I can see that after this, I'll do one more object down low, and then we'll go up to Cygnus and start looking at some of the objects there, which I think are really cool.
Bon was asking about constellations earlier.
Who was?
Bun.
Oh, yeah.
And how you can see constellations, and I was telling her that we could see the entire constellations in Stellarium there on the right in the star chart.
Yep.
Actually, we were in Scorpius, Bun, when we were looking at Messier 4, that globular cluster, earlier on. It's off to the right of Sagittarius.
Okay.
On the other side of the Milky Way.
Yeah, and if we...
Hint, Mark.
Yeah, I know. I'm trying to pull out here to show you. If we look to the right of Sagittarius, you can see Scorpius the Scorpion, and it's right here. Right there. And there is Antares, which is that beautiful red star you see. Now, Scorpius is one of the constellations which actually looks like what it's supposed to be. And that's kind of cool.
Yep. Antares is the heart.
Yep.
You see the tail curling down to the left and then back up.
Mm-hmm.
The two stars close together there are called the cat's eyes. And those are the stinger of the scorpion, Shaula and Lassath.
Yeah, stay away from there.
Cat's eyes are pretty, though.
Yeah, they are. They're really pretty. And right now, just out of here, we have Libra, and that's where the moon is right now. The moon's in Libra. And it'll be in Scorpius probably tomorrow. And trying to see. It moves eastward each day. Okay, so let me turn this off. Okay, so we're back up in Scutum here. And look at this. So now we've done a lot, and you can see up here in the upper right corner, there's like this red nebula, and there's another one here. There's a lot of detail in this image, and a lot of this dark modeling. Now, to be fair, I've also taken pictures of a wet driveway, and it looks like this. And I've used them to fool people as a joke when I was doing some astronomy classes. I said, what is this? What constellation is this in? Oh, that's the Milky Way. Yeah, no. You know? Kevin says M23. Kelvin says M23. And Daryl says, oh, Kelvin, are you saying that's what you think this is at measure 23? Yeah, as Daryl just pointed out, that is measure 11 that we're looking at right now. Up in Scutum. And so we back out, you can see the star cloud very, very clearly. This is a beautiful star cloud. A lot of older stars in here. If you zoom in, you can see a lot of red stars. And a lot of these stars, and see, there's so many stars that they literally, they overlap each other. You know, it's weird. But the red ones, the very, very faint red ones, are most likely M dwarfs. All right. The larger red ones typically are stars that are higher luminosity, meaning they're brighter intrinsic brightness, and that usually comes from a bigger radius. So, and you can't always depend on that, because some of them, there are brighter red stars in our sky that are just close by M dwarfs, which are sometimes only slightly larger than Jupiter, but they're stars in their own right, you know. Hello, Simon Thompson. Haven't seen you for a while, so nice to see you.
When we look this direction in the sky, we are looking through the thickest part of the Milky Way. So you're seeing many, many, many stars.
Yeah. Hence the wet driveway look, right? Yeah.
If you say so.
It does kind of look like a wet driveway, right? Oh, so let's see. Django, Mr. Django, that's Steven. Steven Smith, how are you? Nice to see you. Steven's off in Belgium, starting his day. And I see here that Eliza says she's a Sagittarius. Interesting. Now don't forget our contest, guys. We're running two contests. Well, we're running a contest for 2 pairs of binoculars. A number between 1 and 1,000, and the closest to the right number will win. And we're giving away 2 pairs of Celestron Cometron binoculars, courtesy of Michael Tarr at SpaceX, and Tiffany Echo, his better half.
So 4 binoculars.
You know, 2 binoculars. So
there you go.
Yeah. Language is important.
Well, I say pair of binoculars myself.
Yeah, that's
casual conversation, but
yeah,
really it's just a binocular.
It is. All right, we're gonna
or 2 oculars.
Yeah, that's right. It's hard, you know, when you've got that kind of thing going. All right, this is
That's
beautiful.
a nice picture. The cluster stands out nicely against all the red of the background.
It does. I'm gonna
They're all kind of white to blue-eyed.
Yeah, I'm gonna redock us here, and I will save this, and then save it exactly as seen. And I'll show you what you're gonna get. Now, all these images go up to our server. You can find it at skytourlive.org. Okay, and you know what? It's all free. If you want to support us in the Patreon, we would love it. Also, if you'd like to go to our Etsy store and buy images that we capture and highly process to the nth degree, we put them on everything from shoes to mouse pads to mugs to travel mugs to blankets. And I have a pair of sneakers that I do my talks in when I do talks around the country, and they're Trifid Nebula sneakers. And people go, look at those sneakers. It's like, yeah, that's my trademark, you know. Why not, right? And we have T-shirts too. You can go to skytourlive.org, and if you want to donate to us, you can. I mean, it's how we go. It's how we move. It's how we get our new stuff. It's how we stay alive, and that's cool. Yes, Mr. Django, we have T-shirts as well, and the T-shirts say skytourlive.org, and one side on the back it says the universe live in real time, and shows a little telescope. It's sort of a cartoon on the back, so it's kind of cool. And we're making those T-shirts available. It's another thing too. We have like 50 products available, but we don't have the T-shirts on the Etsy store right now. But if you're interested in those, we'll get you covered. Okay, so let's say this one more time. We've done enough of this, and let's.
Your face isn't on any of those products, is it?
No, I don't put my face on any products.
Good.
Way.
I need to get a coffee cup. I've said before I don't wear advertising, but
No,
I can always.
My face isn't on any of the stuff because this is what I do. This is it right here. This stuff that's on there. Okay.
I can always use another coffee cup.
All right. I will make sure you get a coffee cup. We just need to know what you want on it, and we'll have to take a picture of it maybe.
I should go look at the Etsy store, I guess.
Yeah. Well, it's right there. Etsy store. You go to the Etsy store. It's SkyTour Shop on Etsy. When you search for the store, you'll see store named SkyTour Shop, and you go there. You'll see all our products. If you go to skytourlive.org, you can just click on Etsy store, and it takes you right to the store. So skytourlive.org is our portal. This stream will be there, listed and shown. Winners of tonight's binoculars will be there as well. Michael Hedrick's with us. Hey, Michael Hedrick. I want to publicly show appreciation to Michael Hedrick. He has supported us, and one of our members who had passed on to the great universe beyond, Michael Hedrick was able to support the widow of this man. That was Papa Tom, who had passed away. So I want to make sure that everyone understands that Michael Hedrick is one hell of a cool guy. I want to thank you, Michael, publicly. All right, we are going to get out of here now. That's a gorgeous shot. And if we look at our filter for shots, see, it weeded out a bad shot in the middle of all this, okay? And then there's two more that it weeded out, probably near the beginning. Let's go back. Yeah. And near the beginning, there's another one, too, that was weeded. There it is. So these shots were bad ones. Now, had those shots come through, these stars would have had little tiny elongated shapes. And we want perfect stars. So this filter I put in is actually, going to be is something I always use now, because no matter how much wind is out there, we're guaranteed to get a good shot. It might take longer if there's wind. Right now, tonight, it's quite nice out. All right. So since I keep talking, I got more elements. So I'm going to do it again. Save exactly as seen. Okay, now let me get out of here before I keep talking and make it mount up more. Okay. So now we're going to go to 1 second shot here. This is our low light mode. And then we're going to go to low light. As you can see, it's sort of green. Now we're going to go here. First things first. Let me do this. I want to show one more object here, and then we're going to move on. And that object I want to do is actually called Measure 20. It's really a beautiful object. Okay, and so we're going to do that one. All right, it's right here. Measure 20 is what's known as an emission nebula, and it's a reflection nebula. It sits above the Lagoon Nebula here, right? And the Lagoon Nebula sits next to the Chinese Dragon, which is here. This whole area is just a gorgeous location. And on a future SkyTour, what we'll do is we're going to do because this is the size of our field. When I put it in, I'll show you. Okay, this is our field size right now. All right, so coming back down here to our Milky Way, if we go back to the Trifid Nebula here, and we center it up and zoom in, you'll see what the field looks like. This red box represents the field. So we take a shot here, we take a shot here, take a shot here, take a shot there, and a shot there, and we have 1, 2, 3, 4, 5, 6 shots showing this whole region. It's called a mosaic, and we'll do that at some point, not now. All right, so let's bring the telescope here. You'll watch the telescope move here above. There it goes, and you'll see the screen change now as we do. We're heading to the Trifid Nebula. It's as high as it, almost just about as high as it gets in our sky. Okay, and there it is. All right, so we'll move to the west a little bit. We'll center it up. Try to keep this cluster in there because it adds some nice interest. Okay, and so what I'll do is now move us in a little bit to the west. Here we go. And then I'm just going to go down to the south just a bit. I'm not going to lose the cluster. It's going to stay there. All right. This is fun. This is a beautiful cluster. There we go. This is perfect. So you'll see this red emission nebula, and if you look at it, it has this interesting architecture to it. All right. It has these tri-lobes here. It looks like 1, 2, 3 lobes. That's why it's called the Trifid. You know, some people call it Trifid, but it only has one F, so it's tri, T-R-I-F-I-D. What does fid mean? I don't know. I never knew what that meant. I didn't even look it up, so I have no idea. But anyway, we're going to actually do an exposure of this guy, and we're going to make it a 25-second shot as well. We could put 25S in this field, or we could put 25,000 for milliseconds, and it will do the same thing. So let's go here now and go into our deep sky mode, and we're going to increase the size of this, and we're done here. So when I go into the live stack, you'll see the previous M11 Scutum star cloud image, and that's in the buffer. This is just a beautiful cluster, and when you get this image on our server, you'll be able to zoom in and check it out and hang out with it if you want. So now we'll clear it, and our next image will be in just 1 second. So here we go, and there it is. That's the beginning of the Trifid. Look at that. See this blue nebula all around it. Very, very prominent tonight, Daryl.
Yeah.
So I'm going to go into our histogram now. Our curves need to be aligned a little better, so I'm going to color align just like that, and now you can see better how that's supposed to look. All this red is nebula surrounding this. If I back out, you'll notice what a beautiful field this is. Look at all this red diffuse hydrogen emission nebula that we see here. This is called diffuse nebula. It's hydrogen atoms that have been ionized by nearby hot stars. And most of these nebulae, the stars that are ionizing them, we might not even see because they might be buried in these black clouds, these dark clouds, because these are all dark clouds of dust that we're seeing here. Okay, this is just stunning. This is a beautiful image. Let's see if I can pull out a little more detail by sliding up our black level a little more. Oh yeah, look at that. Wow, that's something. Okay, let me zoom in now. Look at that, guys. That's beautiful. All right, what I'll do now is I'm going to bring up the image annotation here, and it will show you right away the Trifid Nebula. This is the Hipparchus catalog star 88298, magnitude 5.72. Trifid Nebula here, it's a magnitude 9 nebula. It's just beautiful. And then up here, this is an open cluster, and this is open cluster NGC, which stands for New General Catalog, and it's 6531, and that's why I wanted to leave it in here because it's pretty cool. Yeah, look at that. Really pretty. So what I'll do is I will zoom out of this for just a moment. Okay, so now you can see the full extent. And now I will save this image just like you see it here. Alright, save it with the annotation. So now, if you go to look at this and you want to know what it was we're looking at, well then you can just pull up this image right here. And you will see this. It will give you all the annotations. This is the image that's saved on our server. Okay, and these are all free. And you go to skytourlive.org and it'll tell you how to get to our details there. Otherwise, you can wait for our app. We have a SkyTour Stargazer's Companion, which was written by none other than Izabela in our chat, and it allows you to search for several years worth of Trifid Nebulas we've done, or anything else we've photographed in the northern hemisphere, galaxies, nebulae, star clusters, weird events, lunar eclipses, etc. And you'll get to see all this data for yourself, and you'll be able to look at the pictures, and you'll be able to play with them. You'll be able to do all kinds of things with them. All right, so I'm going to, if I say, I'll just do this here. And this is Measure 20. I know that, of course. So I'm just going to put Measure 20. And I didn't want that. Measure 20. No, don't do anything. Stop. All right. Measure 20. And that's going to be... why is it doing that? Maybe I can't use that? Okay, that's weird. I don't know why it's doing that. Alright, Measure 20 is good enough, I guess. What am I missing? Alright, well, I'm just going to save it. Measure 20 is the Trifid Nebula. Trifid. Okay, so we did 9 and we rejected 2. But that's okay. Alright.
I assume you're going to do M8 next.
I was actually going to jump up to Cygnus after this, actually. I wasn't going to do M8 tonight. There.
It's big and beautiful, and it's right next door.
I know. Hey, Ronald's here. Hi, Ronald. Oh, Sam S., why'd you retract that message? I saw it before you retracted it. Okay, we're running a contest tonight for 2 pairs of binoculars. Don't forget, we're running out of time. It's a 1-hour contest run by Tiffany Echo and Michael Tarr, who are in our chat. They are our amazing donors of equipment to SkyTour Livestream. We're their exclusive distributors. And a number between 1 and 1,000, if you're the closest to our selected number, you will get a pair of binoculars. And we're giving out 2 pair of binoculars. Okay, so you only get 1 guess. So if you have put in more than 1 number, you are removed from the contest. So you can't do that. All right, you've got to only make 1 guess, because otherwise you could say, okay, 1, 2, 3, and go all the way to 1,000 by the time the stream's done. So no, it's not fair, and so you have to just have 1 numerical guess. Okay, so if you put in more than 1 number, oh, Mr. Django's got to go to work. Nice to see you. Thank you for coming by. Make sure you guys go see Django's Backyard online. He's got some cool stuff up there. Look at that. This is actually looking nice, Daryl. Look at this. Let's zoom in some more. Wow, look at that.
Blue showing well tonight.
Yeah, the blue is all the way around. Yeah. So here you see most, in one shot, in one object, you see most of what we see in the universe at different colors. We see the blue reflection nebula, it's called. It's really a nebula caused by the scattering of starlight by tiny dust particles, which are these dark lines here that aren't doing any scattering right now. These are lines of dust, but there's also lots of dust out in the interstellar medium. And out here, they're scattering the starlight. But when they're very dense, they may look dark. And we see it here. Okay? And what happens is, when starlight is, hits a dust grain in space, the high-frequency light is taken in and basically reflected off effectively. So it's released back to the interstellar medium in all directions. Okay, and this causes the high frequency light, which just happens to be blue, to show up. And so we see it. This is scattered light off the dust grains. There's a lot of dust in this whole region. In our sky, we see that too. The molecules in our sky of oxygen and nitrogen will also scatter high frequency light coming from our sun. And so when the sun is on the horizon for sunrise or sunset, it looks red. The reason is because the sky has been, the air in the sky has been scattering a lot of the blue light from the sun. And because Earth is curved in a spherical body, we're looking through more light when the sun's on the horizon. So more of the sun's light, the blue light in fact, is getting scattered. And so the sun looks redder than it is. The sun is really almost white. All right. So we see a red sun on the horizon in morning or night. All right. And the sky during the day is blue in every direction because of the scattering done by the molecules in the atmosphere. And so that particular scattering is called Rayleigh scattering, and that's what we see. All right. But you notice clouds are bright white, right? When they're just isolated cumulus clouds, when they're in full sun, they look bright white. Well, why don't they look blue? Because water vapor is H2O, right? 2 hydrogens and 1 oxygen. And that molecule does a different kind of scattering of starlight. It actually scatters all the light hitting it, meaning that clouds will look the color of the sun, and that's white. So that's why clouds are white, is because they're scattering the starlight from our sun. Okay, we've got 21 images here, and this is really looking pretty. I'm seeing a feature I haven't seen before. I'm seeing this halo here. See that little arc? You see that right, Daryl?
Yes, I see it.
I'm wondering if that... Yeah, it's got to be a real artifact. That's going to be a real thing. Look at the beautiful colors, guys, huh? I'm going to add an enhancement to this. Let's do one more. This is going to sharpen everything up. Check this out. Watch now. Look at that. Now we've sharpened up the inside. Now you can see all these really, really fancy tendrils in here. This is a very complicated thing inside here. That's really beautiful. That's really pretty. Let's back out a little bit. Wow. Yeah, that's pretty. Okay, we'll turn it off. We don't use it every time. All right. Okay, 23.
Ronald, I'm sorry, let me answer.
Yeah,
Ronald.
sure. Go ahead.
Ronald, if you looked at this right through the telescope, you probably would see, you can see the Trifid nature of the nebula. You probably would not see any color.
Yeah.
If you did see any color, it might look slightly green to you.
Yeah.
But you can see the 3-lobe nature of the nebula by eye in the telescope easily enough. You have an 8-inch telescope, right? 8-inch Celestron, I believe. So you'd see it quite well. You just wouldn't see the red or the blue.
All right, let me just reiterate. Tiffany says, if you haven't made a guess yet, we're giving away 2 binoculars tonight. Number between 1 and 1,000 will win a pair of Celestron Cometron binoculars, and they're picking 2 winners. And you can only guess once, and it ends at 10 p.m. Pacific? That's 2 a.m. here. I don't know. That's
16 minutes from now.
10 p.m. Pacific?
It's 11 p.m. here, so that's 16 minutes from now.
Oh, I guess it is, huh? Yeah, okay, good. That's right, so we have about 15 minutes left.
Mark, excuse me for a moment, please.
Sure, go ahead. All right, well, there is the Trifid Nebula. It is stunning. And, you know, this is our annotation for it that you can see. Okay, the stars in the field are also labeled, and all as well as some of the other objects here. We'll save this annotation with this beautiful color as well. There we go. That's really pretty. Hey, C&D boy, how you doing? Okay, now what we're going to do is we're going to save this just like we see it. It's a very good night out there, by the way. The Trifid Nebula, being kind of close to the celestial equator, is 21 degrees off, but it's still it's somewhat close, 23 degrees. It's really hard to guide on sometimes, but with the slightest wind, the telescope acts like a flag and it bounces around, and we're getting a gorgeous set of photos here. We got 29 so far. We're going to go to 30 coming right up in a second, and then we'll save that. And that final save, 30, will be our final number of images. All right, you're going to get this image. If you go to our skytourlive.org, okay, you can get this image. Our app would show you the image directly, and then you could download it. And our app will be available. We're still trying to get the app up and going. The app is finished. It's ready to go. Izabela did a huge amount of work on it, and I think that you know, all it remains is to actually hear from the company that takes your money, so we can actually get this application up for you. So that's what we're working at right now. Okay, this is beautiful, man. I don't want to leave it, but I got to. All right, we already saved it. It'll be on the server in less than 30 seconds. Let's go back to low light mode here. Okay, and we're going to go, and I'll do this because Daryl said, oh, come on, it's right nearby, and that is this nebula right here, is the lagoon. So we'll go south a little bit. Don't even have to tell a telescope to go to it. We'll just bring the telescope down to it. Then we'll head up to Cygnus, I promise. Okay. Oh yeah, now Lagoon Nebula is another emission nebula, but this one doesn't have a whole lot of reflection nebula, that blue nebula. It's mostly emission, as you can see coming in from the bottom right here. And it's powered by one particular really hot star in the middle here. You'll see in just a sec. Inside this hourglass-shaped part of the nebula right here is an O-type star. These are hot, and they're very blue. And these stars basically power the universe. They actually are extremely bright, extremely powerful. Most of their energy is given off in the ultraviolet range because they're so high energy. But these stars also only live a few million years because they're always going to be destined as a supernova star. They're always going to blow up, and they're always going to end up leaving a stellar remnant behind. All right, so this is the Lagoon Nebula. We're going to go up just one more click right here. Okay. And
that looks suspiciously like the lagoon.
And it is.
And I thought you weren't going to do the lagoon.
I'm doing it because you asked for it.
All righty then.
All right. So now that we have it there.
That reminds me, when I was a kid, we drove from Missouri to California.
Yeah.
And we crossed Arizona, and we passed a sign that was the turnoff to Grand Canyon. And the sign said Grand Canyon that way.
Okay.
My dad said, well, there went the Grand Canyon, boys. We're not going to stop.
That's funny. Well, not so funny. Too bad, Dad. I'm sorry to hear that. All right.
You reminded me of it.
That's right. Yeah, there goes the Lagoon Nebula, guys. The Lagoon Nebula is known as Messier 8. What's going on here? Why is this not allowing me to type in there? It should. Oh, I think I may have a stuck keyboard again. I mean, it's fine. I can use it, but wow. Okay. Woo-wee! Look at the trails leading around there. Okay. Yeah, stuck keyboard. This is called a shift state error, and I'm trying to just add to the name here is all. Okay, that should work now. M8. There we go. All right. So there it is. And we've centered it in the view. And now what I'll do is we'll take a nice long photo of this. We're going to do a 25-second shot of this. Like that. It's off and running. We will drop this. If you notice our progress bar over here, that yellow bar over there, right where my arrow is, that's where you should look to see how long it will take for this exposure to be done. There's the Trifid we did. So we're gonna look at that's just beautiful. You can see this blue all the way around. That's really, really something. Yeah. All right. So we'll clear this and wait for our first lagoon shot, which should come in right now. Look at that. Wow. That's pretty. Now, if we zoom in on this right away, I'll just show you real quick. Here is that area that I was telling you about, this hourglass-shaped figure. And using our processing, we can kind of remove a lot of that central brightness to kind of isolate that and show you a little bit more about what that looks like. We're going to process that out right now. Okay, so now you can see right here this beautiful hourglass shape. That's the shape associated with the O star, which I believe is this star right here. And this star is powering this whole nebula. Okay, certainly there's lots of dust that's acting like reflection nebula in here, and lots of hydrogen gas that's being excited to the point of ionization by that O star. Okay, so that's true, and I'm gonna do a color correction, and then I'm going to process a little bit more here to show this. Look at that. That's the lagoon. Really pretty nebula, and I'm going to do this like that. Okay, so you can see now this beautiful image. See, here's what happens now. There's a young hot cluster in the lagoon right there, and let me just kind of show you what that does. This hot cluster right here, young cluster, along with this star. Okay, this star has very, very powerful stellar winds. Okay, right there, and these powerful stellar winds are blowing and pushing dust with those stellar winds, and the clusters, what they do is they form a cavity, an opening around and inside the nebula in which they form, and they push this material away, kind of clearing the way. So you see this giant area around. You see this big opening here. Much of this was created by these hot stars, pushing dust away. All right, and sometimes if dust is dense enough, all right, it won't be able to be pushed away. Okay, and so it'll stick around, like this central band that you're looking at right here. This central band is quite dense, and therefore it is not showing any stars behind it, because that's in front and the rest of the nebula is behind it here. Okay, all right, same with these little spots. You'll notice that these have some really interesting features. Okay, you look at this and you say, wow, there's a line of density, there's a dense knot right here, and then we see like a trail behind this one. We see the same thing here with a trail behind this one. So what could that be due to? Well, there may be a hot star buried in the dark nebula out here that we don't see because it's being obscured by the dark nebula, and it could be pushing some of the dust that's in this dense area away and making these trails behind it. All right, that's a possibility of what we're seeing there. I do not know that for sure. So this particular nebula is just really pretty for what it does to us in terms of our view. Let me get me down to the nebula here, because I actually didn't. Yeah, so that hourglass cluster is what that's called, and that's just the Herschel 36. Also, that's the name. So this is actually trying to remember the distance of this. Is it several thousand light years, I believe? I don't remember the exact distance though. It's like 3,500 to 5,000 light years away. I'm not sure.
Something like that.
Yeah. So anyway, that's pretty cool.
Ray mentioned it earlier.
Yeah.
Can you zoom out in Solarium for a second? See M8 here and M20 just above it sit right above the tip of the spout of the teapot in Sagittarius.
That's M20, that's M8. Messier numbers, the Messier catalog created by Charles Messier in the late 1600s. Started compiling a catalog of just over 100 objects, which are known as the objects to avoid if you are looking for comets, because these were things that weren't comets. It turns out they were much more interesting on their own anyway. And once again, Tiffany Echo says, if you haven't yet guessed a number between 1 and 1,000 to win a pair of Celestron Cometron binoculars, we are running a contest tonight, folks. And we are going to pick 2 winners. So 2 sets of binoculars are going out tonight. You can only guess once. The contest ends in 4 minutes. And it's between 1 and 1,000. And Red Angel, you have guessed... oh, I'm sorry, you did not. You're saying... oh, is JSCO here? I didn't see him. JSCO, how are you doing? We are looking at the Lagoon Nebula here. Wind's picking up a little. I've noticed if you look at our full width half maximum here, you'll see, let me see, there we are. If we zoom out, you'll see there's some rejected shots here. Because, yeah, JSCO already won the telescope. So how you doing, brother? Yep. Excellent. Yeah. We're going to go to 10 exposures on this because it's taking some time.
Wind must be picking up.
Yeah, that's what I said. I think that's probably it. But we got perfect stars, and that's because we've got this filter in place. Let's see if this one works. Well, that's good. Yay, we got our 10th. Okay, so we're going to save this. All right, and save it exactly as seen. There we go. There's Lagoon Nebula. It's known as a stellar nursery. Stars are born here. Let's zoom in on this shot, by the way. Let's do this. Actually, let's wait a second. Here we go. We can do 1 second shot here. All right, there we go. Now, Lagoon Nebula is quite bright anyway. So if you zoom in, see, here's the hourglass, okay? And there's your O star, I believe, right there, that's lighting up a lot of this region. You'll notice a relatively spherical distance here. A knot of nebula here is being illuminated or ionized. If you were there, the temperature in this region is going to be quite hot. We're talking thousands of degrees. 1 minute to your guesses, so put in your last minute guesses. Contest ends in a short amount of time. Kevin O'Neill says 687. All right. And, all right. And, again, if you threw up more than one number, you're disqualified. This is one number only. It makes sense, right? So let's do this. Let's come out here. Once the contest ends, Tiffany will tally the potential winners and let you know. Okay. So now what we're going to do is we're going to back out of this. We're going to go to... Oh, I didn't want to do that. Sorry. We don't need this histogram up now. And we're going to go and zoom back out to fit the width. There we go. Aren't the stars beautiful, guys? It's just a beautiful, beautiful location. I've always dreamed of being able to look at the sky effortlessly, and this helps us do that. And now we're going to go up here into Cygnus, and I want to look at something in particular that's here. That's a Cygnus star cloud. I want to take care of looking at a different type of star that's here. And it is the Crescent, known as the Crescent Nebula. Right there. And let's see if we can go there without incident. Alright. And we're going to go here. We've got a 1 second shot. Telescope's heading up to look at it. That's about right. We are now up in Cygnus. And there is our object of interest. We shall move over to it. This is a nebula created by a particular star. And usually when we see nebulae created by stars, the stars have died. They have gone past their usefulness. They've used up all their hydrogen. And they've gone to the point where they basically slough off their outer layers if they're stars like the sun, or explode into supernovae like some stars do that are very massive. Well, in this particular star's case, the star's right here. It's still there, but it's made this nebula around it. Now, wait a minute. What's that? Well, this is a star that is known as a Wolf-Rayet star. And Wolf-Rayet stars are exceedingly bright and exceedingly powerful. And what happens with Wolf-Rayet stars is that they're extremely hot, like 45,000 Kelvin, all right? And this is a region. Now it says H2 ionized region. Yes, that's true, but they're not telling you the true nature. It's actually this WR star, Wolf-Rayet star. And there's several kinds of Wolf-Rayet stars. You have nitrogen ones, you have carbon ones, oxygen ones. So you have WN, WC, WO. Okay. And in this particular case, the star has blown off its outer layers, and it's now exposed its bright hot core. And when we look at the spectra, we can tell what kind of chemistry is going on there, what the composition is, and that tells us what kind of star, what kind of Wolf-Rayet star it is, whether it's a W oxygen, W nitrogen, or W carbon. Okay, and I don't remember which one this one is, but it's easy to look up. So, but this is definitely it's a really interesting location. And when you watch this one develop here, we're going to do 25 seconds on this. You're going to see a really incredible view. I'm going to drop out our low light mode, and we're going to go into deep sky mode. We'll get rid of the last deep sky object, which is that gorgeous lagoon, which we saved. I'll save it one last time. Actually, I don't have to. I'll clear it. All right, I already did it. All right. Now the histogram is the color curves for all of the light coming in. It's red, green, and blue combination. And there you can see. Now, if you'll notice, you don't see too much. Well, that's because our black level is set past the peak. Now we're gonna do this to align the curves. That changes the colors to what they're more like. Now we move this back to just the left of the peak, and now watch the difference. All of a sudden, a lot more is happening here. And if we come back out here now, let's move that line. This is the mid-range line. We move that in to about here, and now this nebula starts to pop, and we can actually see where it wants to go. This is where it wants to go. All right. So this is a 25-second photo. We'll color correct one more time. See if it changes. It will over time. So now if we back out, you can see the whole field here. Okay, this is called the Crescent Nebula. And the Crescent Nebula is this most amazing object because as the Wolf-Rayet star, it hasn't gone supernova or died yet. It's still furiously fusing. And eventually, however, it's going to go supernova. And quite violently, too.
Is Eta Carina a Wolf-Rayet star?
I don't know.
I know it's very big and very hot and bright, but
is it a Wolf-Rayet or is that?
I don't recall if I've ever seen it called a Wolf-Rayet star. I mean, it's a huge star.
It is. Let's bring this in more. And now let's go out here. And let's climb the curve again to start bringing in some contrast. Look at that. Wow. Now keep in mind, guys, we have in the sky tonight, we have a moon that is just past first quarter, meaning it's just past being half lit as seen from the Earth. The half lit, fourth of the way around its orbit around the Earth, just past that. So the moon's pretty bright, and for us to see faint nebulae like this is pretty good. All right, so let's pull this down just a little.
Mark,
yes, sir.
Tiffany is giving Bun and Keith Evans instructions on getting your shipping address. I think they would need your email address.
Oh, thank you. Yes, if you guys want to reach us, it's very simple. If you go to skytourlive.org and you go to contact us, a form comes up, and put in your data, and we will make sure. Now, did Tiffany announce the winners? Obviously she did. She says congrats to Bun and Keith Evans. You guys are the winners for tonight. The winning number was 49. Why that number, JSCO asks? Well, that's because today was Michael's birthday, and you'll never guess what that number was. What was his age? 49. Fantastic. Well, congratulations to Keith, and congratulations to Bun. Bun, I think this was your first time in the stream, was it not? So I think that's pretty cool, and I think it's Marianne's fault that you won something tonight. If I recall, am I wrong about that? You let me know. Okay, there is the Crescent Nebula. Look at that. Wow. Okay, once again, guys, make sure you go here, skytourlive.org, to our portal, and you go to the Contact Us. Go and fill that out. Write us, and we have your name. So if for some reason you can't, don't worry. All is not lost. It doesn't have to happen tonight. You can do it tomorrow. And then what that'll do for us is it'll allow you to get listed on our webpage as winners, and we will then send out everything to you. Congratulations. These binoculars are a blast to use. I'm really liking this. Let's do this extra enhancement here. Let's add some detail to these tendrils. Ready? Here we go. Look at that. Wow. This camera and telescope combination, I've mentioned this before, and Daryl knows this, have been tuned to our focal length, which is 1.8. Our f ratio is 1.8. So it's an f1.8 scope, so it's very, very fast photographically, meaning 25 seconds shows you this nebula and faint nebula all around it. Look at this. Look at all that faint nebula around it. This is all diffuse nebula. Some of this is associated with the Gamma Cygni Nebula, which is that way in the image. It's over here, okay? And some of it is associated with other nebulae in the Cygnus star cloud, which is to the right and up here. Really, really beautiful. And so you're seeing dark splotches. Those are not holes in the stars. Those are actually, again, dark nebula in the foreground, hiding the star clouds in the back. That's pretty cool. Sorry about that. It keeps doing that to me. Wow. Yep. Bun says, yep, definitely her fault. She encouraged you to vote. I wasn't going to because I didn't think I could win, but I'm glad I did. Also am I. See, now you will forever be hearing from Janie, who is going to say, Mom, can I use those binoculars? And I'm sure that you'll say yes. She wants to learn astronomy. There you go. You explore the night sky with binoculars. That's how it begins. I had binoculars as a kid, and man, looking through two eyes up at the night sky was amazing. And the binoculars I was using were made in the 20s, and they were on a German soldier in World War II. And when my father captured him, he took the binoculars and he sent them home. You know, they could do that back then. So, that said, we have the opportunity here to encourage other people to go out and do... Darn it, stop it. And go out and look at the night sky. This is fantastic. So congratulations, Bun. Congratulations, Keith Evans. I'm very happy for both of you. Very happy indeed. All right. So this is the Crescent Nebula. What do you think of that? Isn't that beautiful? Let's bring up our target again. And we'll save this image with the annotations so people know what they've got here.
Mark, JSCL asked an interesting question.
Cassiopeia A?
Yeah. I don't recall us ever imaging it.
I've done it on my own, but we can see. I imaged Cass A. It's sort of like a blue-green splotch around the star, the remaining star. I think that's the one we're talking about. You know?
The supernova remnant in Cassiopeia.
Yeah.
I forget, was Cass A the last visible supernova?
Yeah, I think you're right. All right. I mean, while we're here, we should just do the North American Nebula, right?
Well, that's not it, be sure.
It's up by Deneb, yeah. It's up here. I was thinking maybe we should do that. Notice the field of view, it's going to be kind of small. The whole nebula's here. That's another mosaic, but it's a lot of mosaic. I actually mosaicked one time this entire Gamma Cygni region. And that's available in our app. You can go find it and see it. But notice, guys, how after a period of time, the imagery presents much better. Because what's happening is, in the stack, we have 23 images here stacked. 25 second images is our target. That's where we're going. We got 23 now. So what happens is, the first image is taken, and then the second image is taken, aligned with the first, and slapped on top. And we build an image sandwich. Why do we do that? We do that because as we build this image sandwich, a lot of the random noise created by the digital imaging is removed. So when we zoom in now, you'll see that if we zoomed in on the first one, this would have been very difficult to see any of this detail in here. It would have been really hard to see. And to be fair, if I just take this off for a second, okay, this is now, when we look at just black space, you'll see that the image in here, normally we'd see lots of noise in here, but now we don't, because we've got 25 shots we've taken here, which I'm going to save right here. That's beautiful. Really stunning. And if
when we look up into Cygnus, you might remember when we were looking over the tip of the spout of the Teapot Sagittarius, you're looking toward the center of the galaxy. We're now looking at a right angle to that. We're looking about 90 degrees away from the center of the galaxy, up into the spiral arm.
Yeah.
And it's another very rich star field.
It is. And if we keep going further up, we're going to look into yet another region, which is going to be in the Cassiopeia region, and it's going to be a more distant arm as well, the Perseus arm. And that's going to happen later on in the season. But there we go. And I'll save this as it is here. That's just stunning. It came out beautiful. All right, so I'll save this one more time. And then move on. Move on. All right. So again, that's a Wolf-Rayet star. It's ejected its outer layer. The red is ionized hydrogen. And you can see hints of other colors in there, probably oxygen, right, that's out there. And again, the temperature in this region of space, at least on particles, they're absorbing radiation that will send their temperatures to 45,000 Kelvin, which is a temperature scale. And when you hear Kelvin in Fahrenheit, it's much higher. So we're talking very, very high temperatures. So the atoms don't exist as atoms out here. where you have protons with electrons. All you got is protons because the electrons have been pounded off the atom with this high frequency ultraviolet radiation being given off by that crazy star right there. That's how it works, right? So when we look at anything in this region, you know, keep in mind here. Okay, here's the crescent in here. The star we're looking at again is this guy right here. That star right there. That is our basically progenitor, if you will, of this nebula. Yeah. All right, so that's
Wolf-Rayet stars are pretty rare.
they are.
I forget how many we know of. It's like 200 or less, isn't it?
It's less, yeah. I think it's again they're somewhat rare, but I think that's only because they're probably short-lived.
Yes.
And so we're not getting to see them because of that reason. All right, one more save, 33 images, and then we're gonna move on. Again, skytourlive.org, or I would just target you to go look in our app once it's out. We're getting there with the app. The app just, again, the company that I'm trying to get to take our money just hasn't got back to me yet. I don't know why. I know they like me.
They like your money.
Yeah. Now, we are a nonprofit company, so I think that's what's taking the time. They're trying to confirm our nonprofit status, and maybe they have to do it with a physical piece of mail, and they have to depend on hearing from the IRS or something on this. I don't know. Okay. So now what we're going to do is we're going to back out of here. We're going to go into our planetarium, and we're going to run over very quickly to the North American Nebula. This is a beautiful nebula. All right, we're going to center on that. And like this. All right. So here we go. Off we go. Telescope, you'll notice it's going to move just a very little bit. There it goes. Stars move in the view here. Satellite going through at the same time. And then you'll see our crosshair come in. Zip, and it's going to center up in there. All right. There we go. When we come in here, you'll actually see some cloudiness, all right? But let's zoom out to the full size so you can actually see what we're looking at. Okay, we'll fit by width here. Fit width. There we go. All right. Now we'll try this. We're going to do our analysis here to identify what's in the view, and as you can see, there's lots of stuff in the view. And the H2 region there is, as you can see, we're going to head to the west a little bit here. And I believe that it should be able to relabel as we go. I'm going to pull over here. This is a relatively new feature where we can carry our annotations over. Yep, that's good. All right. Okay, so not sure exactly. Okay, there's the star cluster plus nebula. Let me go look here and see if we can see that. I guess I just have to take a picture to see because I can't tell. That bright star was kind of where you wanted to be, I think. That's just outside the field. All right, here's what I'm going to do. I'm going to take a picture, and that'll tell me right where we are. And this will be a 20-second shot, quick shot, and we'll go into our live stack. Come out of low light, go into live stack. Clear the last one.
Good night, Bun.
Good night, Bun. Thank you for being with us. All right, and let's see what we got here. Oh, look at that. Okay, I see where we are. Yeah, I'm almost exactly where I wanted to be. I just have to go a little further south. So that's what I'll do. All right, 1 second. We'll just move a little further south. I thought I saw that there too, and I didn't act on it. All right. It's right here. I wanted to actually view the wall, the Cygnus wall, which is right down here. It's like right here. This is probably right where we gotta be. Maybe a little further, tiny bit. This is a beautiful region. When you look at it, you're gonna say, wow, that is just stunning. You know, wall-to-wall nebula, dark nebula. All right, just beautiful. This image will be a 25-second image as well. You know, so we're taking pictures quite rapidly. There's really no one doing what we're doing. You know, a live observatory like this that's instructing you in astronomy and showing you really cool stuff. Right, here is that part there. There's the wall. We're gonna go a little further south. I'm not gonna start the exposure yet. Okay. And I'm gonna move a little to the west. Just a bit. Okay.
We'll be looking roughly at the Gulf of Mexico.
That's exactly right.
In the North American Nebula.
Yeah, the Gulf of Mexico is going to be right about here. And then the wall is going to be right about here. You can even see a piece of nebula right there. Okay, so let's now go into our deep sky mode. Our exposure is underway with our magic school bus telescope. See, that's the image we shot before. I'll clear it. And you'll see it again. Now this camera, this is the first time I've taken a picture of this with this camera. The previous camera showed it, but it didn't deliver the right colors because it wasn't really well tuned. This camera is better tuned, so the colors are going to be richer. And it just is stunning. It's really, really pretty. Okay, look at that. That's really pretty. So this is the Cygnus wall right here. How beautiful. And there's lots of dark nebula down here and below. So this is going to be a beautiful image. I could drop it a little, huh? I don't want to drop it too much, though.
Drop it.
Yeah, it'll go this way. You'll bring it down. But there's interest here, too, so... all this dark nebula, these tendrils I want to get. Look at that. This is beautiful. Now, this is really probably one of the most beautiful regions in the summer sky besides the Lagoon Nebula. And this is called the North America Nebula. All right.
We're just seeing the southernmost part of it. Right
Oh, we are, yeah. We have to mosaic. The previous camera
That's
showed
Mexico.
Yeah, right here.
And the tip of Florida up to the upper right.
Right there. And the beginning of the Pelican Nebula over here, which is another element. So, as far as... Okay, this is what we see for stars in here. The nebula is actually kind of outside of the range of this, even though this is all part of the nebula. Okay, I really like this region here at the bottom of the wall. This is just gorgeous, gorgeous. Yeah, and I didn't even color correct yet, so let's go do that. Alright, so color correct. Look at that. Wow. And let's see where this wants to be. It's gonna move a little brighter. Yeah, that's okay. I'm gonna climb the wall a little bit here. And then pull this in a little. You move these two closer to each other, it's a push, and you get more detail, subtle detail in the dark. See, when I do this, you'll see it gets really, really bright. Okay? But you see lots of detail in there. So that's gonna come when we're out here as well. It's just gonna take a little extra time. That's all. And the moon adds a little extra blue color, so what I do is I manually take the blue out over here to make it more correct. But look at that. This is just beautiful. And down here we have these beautiful this right here makes a beautiful shot. Just this. JSCO says that's incredible. It really is. It's just beautiful.
And looks like Mexico's really happy to see us as usual.
Yeah, notice if you look at this carefully, this actually streaks back this way. There's a lot of detail back here. If you watch when I take this and move it over, right over here, drag out more detail here, you'll see there's actually these lines going back. That's this material being driven further back by some other process, either its own motion or from bright stars inside this nebula that are actually causing this to illuminate, or possibly from the star Deneb. If we go up and look in here and we zoom out, you'll see the star Deneb here. This is a very bright star, and this bright star and this nebula, I believe, if we go to Deneb and we look at its distance, all right, we'll see that its distance is somewhere, it's 171, no, it's about 1,500 light years, 1,400. And the North American Nebula and the Pelican, in terms of their distance, if we look at those, their distance is about 1,600 or 1,700 light years. So they're a little further than Deneb. So Deneb is closer to us a little bit, and so it's shining on this. Deneb is a hot star. Let's take a look at its spectral type. Okay, if we look at its spectral type, it's an A21A. Now A2 means, and we have the range of the spectra. I'm sorry, the stellar types. It's O, B, A, F, G, K, M. Hottest and bluest to coolest and reddest, which is O, B. Then we have A. Well, okay, that is for temperature. However, the size of the star is dictated by its evolutionary location, where it is in its evolution. And a 1A, if you notice here, that's actually Roman numeral 1 followed by an A, and that means that it's actually a supergiant star. And that means probably that Deneb will eventually go supernova. All right, and the thing that's interesting about this is that an A21A star as a supergiant, and not red means it's very hot, much hotter than a red supergiant. So it's a supergiant star that's also very hot. So it's definitely ionizing a lot of hydrogen in this region, even though it's some light years away. That's fine. It can still do the job. And that's what we're seeing here.
Can you scroll back, show the constellation?
Yeah.
When we see Deneb there, Cygnus is the swan, okay? There you go. There's the swan. Deneb means tail, literally. And as you go up toward the top there, Alberio makes the tip of the swan's nose or its head or its eye. That's a pretty double star all by itself.
It really is.
And if you've heard of the Northern Cross, well, the Northern Cross is looking at Cygnus upside down. Deneb being the tail of the swan, it's the head of the cross, and Alberio is the foot of the cross.
There you go. So we are upside down here.
Yeah.
So that's pretty cool. And now if we go back, you'll see that we have come quite a ways. We've gotten to 18 exposures, and we're actually pretty bright here. If I bring it down to a more reasonable value, you'll see you actually see more detail by getting rid of that overexposed area. Now you can see detail upon detail in here, and this is something that's really cool. Look at that detail. Now if we go down here, this doing stuff like this kind of simulates what you might see in various types of telescopes without the color. In fact, when you look at this, and this is kind of what you'll see. It's going to look like this, right? In telescopes without color, you're not going to see the color. That's because with your eye is seeing momentary images. It's not allowing color to accumulate on the rods and on the cones anyway of your eye. And the rods, which see black and white, are the only part that can see efficiently at night. And the cones can see, but the light, it takes a lot of light impulse to set them off. So you see mostly in black and white. However, our eyes are tuned to see the color green. So many times when you look at a nebula like the Orion Nebula, it's very bright. So it's bright enough to set the cones off, but only the green receptors in the cones, because that's what they're finely tuned to see. All right, so you'll see green a lot, as Daryl mentioned earlier, in these nebulae, especially the bright ones, but only when you're looking visually. With a camera, the camera is completely unbiased. It doesn't have a particular color that it likes to see more, unless you get a specific camera that does exactly that, and there are some. But this is just a beautiful region. And we get to see the diffuse nebula here. In fact, let's drop you down, and let's actually go full screen here. Pull that over, and kind of let you see this full screen. Look at that. So we can drop this down a little bit. You can see all this detail in here. This is stunning. Looks really nice, Daryl.
It does.
Yeah, really nice tonight. It's actually a very still night out there. Let's go check our full width half maximum filter and see what we've got for efficiency of our guiding. Well, that's pretty good. Every single image has come through, and our telescope is sticking up like a flag. And actually, we're not getting any wind. We're past the wind for tonight. It said maximum wind 6 knots out there, so we're good. Wow, very nice. We've got
wood.
Yeah, I know. We've got 24 stack. We just did 25. So what I'm going to do is save 25 of these. Save exactly as seen. Here we go. Okay, and this is just like that, so we're cool. All right. Let's take one more look at this here. Let's zoom in and go around, look around this thing. Here's the lower section. This is called the Cygnus Wall. It's an area of thick nebulae, probably caused by shock waves from supernovae over time that have pushed gas and dust along like a snowplow. And here we see some of this dust. It's really dark tendrils. A very, very complex region of the universe. Here you'll notice what looks like gentle gossamer swoops of dust here. That's exactly what these are. Probably dust blown and moved by bright hot stars within this nebula that we cannot see. So that's another thing there. Let's do this to kind of remove some of the noise. Okay, now you can see a little more detail in there. Look at this very, very specific areas in here. This is all dark dust, and that's up here in the front, and the nebula is behind it. So what you can almost see how this subtle nebula here and this subtle nebula here are the same one, with this tongue of dark dust sitting over the top of it, preventing you from seeing through to the other side. This is one logical connection. And this is sitting over it. Because it's a 3D universe, don't forget.
Closer to us, in other words.
Exactly. Yeah, that's just beautiful.
Well, I know you mentioned a few minutes ago whether Deneb was lighting up the nebula or stars behind that dark cloud that we can't see.
Yeah.
And I know parts of it, at least maybe the part that divides the nebula from the Pelican Nebula, that there are stars behind the dark cloud that are illuminating at least parts of...
yes. Yep. And the A21A, that Roman numeral 1A, is called the luminosity class, meaning it's a very, very big star, and it's very, very hot. That means it's going to ionize lots of atoms in this nebula, and so we see the evidence of that too. So there's a lot going on in this nebula, and it's
Michael.
Yep.
I'm sorry. Michael H. has an interesting question. He says, if we had this telescope set up 5,000 years ago, could we see a difference here? I would say yes. How so? I'm not sure. The sky at a naked eye scale, when you look up at the sky, would largely look much like it did 5,000 years ago, like it does now, with some differences. I mean, some stars moving pretty quickly, and their positions that are changed in the sky.
Yeah.
When you get into a smaller field of view, like we're doing with a telescope here, there's probably a really good chance, yes, it would look different 5,000 years ago, in detail, if not in gross matter.
And if we could compare photographs from then to now, we would see subtle, different stellar positions for sure.
Yeah. There are areas that, like the Crab Nebula in the Horn to Taurus, we can see differences in the nebula over the course of years.
Yeah.
Mere years. 70 years, if I remember correctly, some people have said. But on shorter time scales, because, the Crab Nebula blew up 1,000 years ago, and it's growing larger because it was such an energetic explosion that it's still growing.
Mm-hmm.
And so we can see significant changes in the nebula and the crab over a relatively short period of time.
Yeah, over the past 100 years, we've watched it go ding, 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 ding in several photographs.
Yeah.
Okay, so we just checked that out. That was really pretty. Now let's zoom out a little bit, and we're gonna go over here. Okay, Daryl, east or west or central?
The witch's broom.
Okay, that would be west. This is the location that we're going to look at now. This is the Witch's Broom. It's actually known as part of the Veil supernova remnant. If we look close at this, we zoom in a little bit. Imagine this as a 3D remnant of matter, debris expanding out from the site of a supernova explosion. And based on the composition of this with oxygen and hydrogen gas and much more in here, we know that the star was probably a very hot, a more massive star than our sun, obviously, because it went supernova. Our sun could never go that way because it's too small in mass. So this particular remnant, we're going to check out this section of it. And it's called the Witch's Broom because when you look at this up close, all right, it has this weird pointy part up here, and then it has down here it has this Witch's Broom. Now currently, the way it's arranged in the sky, we're not going to catch all of it in our view, so we'll do our best. This is actually the western veil because west is this way. This is the central veil here, and then the eastern veil is this beautiful object right here. Now,
I'm sure I've asked this before, but I mean, this is a product of a supernova.
yes,
Is there anything left of the progenitor star?
I think there is a pulsar that was left behind, and I would like to see if we can locate it. It might just be an X-ray source left behind.
Yeah.
That's meaning it could possibly be a black hole left behind.
Well, let me look real quick.
All right, and we're gonna go here now. You'll watch the telescope move a little bit toward us effectively. Here it goes, kind of coming toward us a little bit. And that star that you saw in there, that's 51 or 52 Cygni. And that's the star that is sort of like, it's right there. That's 52 Cygni. And we'll bring it in. All right.
Science blurb from NASA says supernova remnant about 10,000 years ago.
Yeah.
Death of a massive star.
Yeah, they say 8,000, 10,000.
The Veil Nebula's progenitor star, which was thought to be 20 times the mass of the sun, lived fast and died young, ending its life in a cataclysmic release of energy. Doesn't say what became of it, and doesn't say if it's anything that is left visible or not. As you said, it might be a X-ray source.
I think it is an X-ray source. All right, we're going to go down and do the bottom of this, okay, right in here. Because this is a very interesting area down here at the bottom. So we'll do that. So let me go and look here. And let's zoom in a little. So that's where we are. So what I got to do is, since I know where we are, I'm going to actually tell it. I'm going to tell it to solve for this region. Yep. And I want it to go there and center in the view. Yes.
Here you go. X-ray source Cygnus X5.
That's right. We've talked about this before, actually.
Yeah. I thought it sounded familiar.
Yeah. Okay, so there we go. All right. So now we have that. And what I'll do, again, is now that we have it labeled up there, I'm going to drop us down to the bottom of this segment to show you this beautiful nebula near the bottom. We're going to put this star, 52 Cygni, which, by the way, is a foreground star. Good night, Judy. Thank you for coming. We'll have more contests moving forward. And folks, don't forget, go to skytourlive.org, go to the Contact Us, and write me a message, and I will make sure that you get your binoculars. All right, that message is for Keith and for Bun, who has left us for the night.
Yeah.
Hope she remembers. I'll have Marianne make sure she does it. Marianne's staying at her house right now. Okay, I'm going to just come back up a little bit. I hope you guys are enjoying this tonight. It's really enjoyable to do this with good company, and you guys are good company. Alright, so we're set. Now I'm going to come out of this, go into our format here. I'm going to do 25 seconds again. You'll notice I keep doing 25 seconds. Could I do 2 minutes? Could I do 5 minutes? Yeah. But why? I don't need to. This telescope runs so quickly that 25 seconds is more than enough to capture the details we need. Yeah, you know, don't forget, this was a 25-second shot. Look at all this real dim detail we captured. It's just beautiful. And this is up in the server now. Okay, Keith Evans said he emailed me. Good. I never use email, he says. All right, I will find out. Oh, look at that. That's beautiful. And for those people that are tired, this is Twinkle Twinkle Little Star. So you can all go to sleep now. Careful, I think that might put Daryl to sleep too.
What's that?
Twinkle Twinkle Little Star is playing right now, but you can't hear it because I don't have the music playing for you. Everybody else hears it but you.
See what I have to put up with, people?
I know, right? Yeah, this is gorgeous. Look at that. Again, 52 Cygni is in the foreground, so it's way up here, and the nebula is way back here. I think the Veil Nebula is about 15 to 1800 light years away, and about 8,000 years old. That's some of the estimates I've read. They could be less, could be more.
I think Wiki said 2,500 light years away, roughly 10,000 years old.
Yeah, I've heard conflicting data about it. It's kind of hard to measure distance to unless you do a dedicated study. Oh. I guess I can't do this without doing the other end of it, huh? I'll have to make a mosaic tonight. What I'll do is I'll just do 6 exposures, save it, go up north, and do 6 exposures again.
We're looking at the, I guess you'd call it the foot of the broom right now.
That's correct. I wanted to get that because it's so beautiful in here.
Yeah.
Let's see if that's going to work for us. Let's go in here. Maybe. It'd be best if we did like more exposure, so I'll Couple more. Now you'll notice that that's not all there is. There's more over here. This is the beginning of the central part of that veil supernova remnant. Then way off the page to the left is that eastern veil remnant, that curved, beautiful bow over there. It's really stunning. Sam S. Next on our hit parade, folks, it'll be the Itsy Bitsy Spider. How I wonder what you are exactly, Kevin.
I am about to turn into a pumpkin.
I know you are. So hang out just a little more. I'm going to do 8 exposures here. And now we'll climb out of here. I've saved it. And we're going to just move a little northward and do the rest of this. We're going to take 52 Cygni and we're going to put it down here. Alright, and then we'll make a mosaic of this for you guys. I think Izabela's lurking in the background. I know she's probably here. Or
Izabela went to bed.
I bet she went to bed then. Okay, alright, yeah. Yeah. She'll catch up tomorrow. Okay, here we go. Okay, so this is the northern part. The northern part of this is really fascinating, and you're going to see it here in just a minute. Again, 25 seconds for 8 exposures. Okay, we're guiding now. 25 seconds. Come on. Alright, let me just waiting for a Starlink satellite because we use Starlink to get all this to you. 25 seconds. Alright. Waiting for the data to come back. Come on. Why is it not doing it? Okay, well, it deleted it. Okay. Let's see what the problem is. Another shift state lock up on the keyboard. I don't want the caps lock on, but it doesn't matter, I don't think. Yeah, okay, so now we'll go into our live stack. And you'll see the southern part of this. Yeah, very brightly. There's a central veil, and that's because we have this histogram pumped up. We gotta remove that, and that'll clear all the buffer. Now you see the northern part, and it looks like a twisted tornado. It's really beautiful. There we go. Now we move you down so you can see there's more to see. So there it is. There is that beautiful peak. Now these are all moving outward, by the way. They're moving outward. This is spreading out. And it will spread out far enough so that the ionized gas will no longer be moving at a very rapid pace. It'll start mixing with the interstellar medium. It'll slow down. In fact, you might be looking at compression of the gas, which is causing it to glow, because the outward motion like this, striking other particles in space, can actually raise the temperature to literally millions of degrees. And that will ionize all this all this material, so make it glow. Yes, Sam S. When we looked at this before, we noticed it looked a little greener. Each camera has a tuned sensitivity. This one is slightly bluer. That's correct. I'm going to try and see if I can alter this to more what we might expect it to be. Okay, now it's sort of greenish blue. See that? A little different from what it was moments ago.
Yeah, that's actually a closer match to what oxygen and hydrogen look like.
Yeah, yeah.
More blue and more red instead of green and orange.
Yeah. Yeah, this is more like it right here.
Michael Hedrick asks, need to go, Mark, but real quick, would my DNA be fried if I was in the middle of that?
Not necessarily, Michael, and here's why. This is as dense as that looks. It's a very rarefied, or the atoms are very sparse from each other, so you might not get fried. If you're near a Wolf-Rayet star, which of course these are not, this is a supernova remnant, and this illumination is caused by collisions with this gas moving outward at a high rate of speed. But in this nebula, it probably has 30 atoms per cubic centimeter. Okay, only 30 atoms. Now, we have like 10 to the 26 atoms in a cubic centimeter of air. So you don't have the same kind of heating. It's each atom can absorb some energy and then radiate it. But such a rarefied atmosphere in there, you probably won't be fried. Of course, it depends how fast you move. If you move through it this way, you move up through it this way, then you might be in it longer, and maybe that could give it time to act on you. But if you're going this way through it, maybe not. But again, this is several light years across, and this material is all spread throughout the interstellar medium. You might recognize a subtle increase in the temperature, but I don't think your spaceship's going to get fried moving through it. You might actually you might be able to detect that there's a temperature increase on the hull of your ship, but I don't think it's going to fry you.
Yeah. I dare say if you were flying through the Crescent Nebula, especially if you were anywhere close to that star,
Yes,
you would be fried.
that's Wolf-Rayet stars, different story.
And if you were near the O star in the Lagoon Nebula, you would be fried.
You would indeed.
Yeah, where you're anywhere in the neighborhood of really energetic stars, I mean, those neighborhoods aren't good for life.
Correct. Okay, so we got...
In this case, there, the bright star you see, 52 Cygni, it's actually a foreground object.
Yeah.
It's not physically involved with the nebula,
Correct.
just in front of it.
All right, folks. Well, Daryl is becoming a pumpkin. I do have to get up early tomorrow. It's 2 o'clock in the morning here. Let's take a look at our night sky, AllSky. There we go. Moon is setting. There's our Milky Way. And we'll review it in the morning, because if there's going to be meteors from the Perseus, they're going to be up here. If you notice our compass rose, here's north is up here. And so kind of in the northeast, we're going to see any potential for that. And up in the northeast, we have constellations like Cepheus. Okay, we have Triangulum coming up, and Andromeda is sort of on the horizon. Okay, Cygnus we just played in for quite a while. All right, and we will be playing with more of these constellations soon. So I hope you guys have a good night, and I want to thank you for joining us tonight on SkyTour Livestream. So on behalf of Daryl Mason and myself, I want to say thank you all. I hope you enjoy the binoculars. Make sure you text me. Keith Evans wrote me. I'll make sure I get that message. Don't worry, Keith. We haven't forgotten about you. And Bun, of course, is probably sound asleep by now. But she's getting a pair of binoculars as well. So there you go. Sky Tour giveaway successful. Thanks to Tiffany and Mike. So you guys have a good night, and we will talk to you next clear night. See you later, everybody.
Good night, everybody.
So long.